Hello, Algebra 2 class. How are you doing? It is Friday, and I have no tie. Pretty normal. Put a little check mark when I get back to school. I think this is day 8. I could be wrong. I don't remember. I don't have the check marks. So we'll go from there. Anyway, it is the day before spring break, technically. So next week, we will not have any new assignments. You will be given some opportunities of doing other things with the school that you'll get an email about shortly if you haven't already. In the meantime, we're going to do the last lesson before break, and it's the third lesson of the chapter. This lesson involves finding square root functions and their inequalities. If you remember, on our last lesson, we talked about the inverse functions, and inverse functions of lines are just different lines. Inverse function of parabolas are sideways parabolas. So an inverse of a square should be a square root. So we're going to see those relationships today and talk about that. But the objective for today is to graph and analyze square root functions and to graph the square root inequalities. Let's start with an example. So here is a parabola. It's a parabola that you know, x squared minus 4. You can probably graph it really fast without even me saying anything about it, but I wanted to just give it a little table so we can get some specific values. I also want to graph its inverse. So if I put in negative 3, negative 3 squared is 9, and 9 minus 4 is 5. Negative 2 squared is 4, 4 minus 4 is 0. Negative 1 squared is 1, 1 minus 4, and so on down the line. 0 squared is 0, 0 minus 4. Now, if you remember, since we're squaring it, negatives and positives become the same. 1 squared is 1, 1 minus 4. And you can see that repeated pattern now with the parabola because it is symmetrical. And our vertex will be here at 0, negative 4. All right, now here's my attempt to draw. It's not quite right, but it's smooth, so we'll keep it. And over here, we'll try to do this side, bring it down, and we'll call that good enough because it's hard to still draw with this for me. Okay, let's graph its inverse. So instead of solving for the inverse, I'm just going to do it the easy way. I'm just going to invert these points. So 0, negative 2, negative 3, negative 1, negative 4, 0, negative 3, 1, 0, 2, 5, 3. Now you can just tell by this table it's not a function because 5 can't give you two values. 0 can't give you two values. Negative 3 can't give you two values. X's can only give one value. Here it gives you two. But it doesn't have to be a function to have a graph. So let's graph them. And you'll notice it's the same exact thing we did with the other function, except this is kind of a sideways parabola. I did a little bit better that time. Still working on it. And there's the dotted line where it should be a reflection over. And the two graphs should meet right along that line. They didn't quite, but we said math before. Just make the lines bigger to fix that problem. Okay, so that's the inverse. Now the inverse is not a function. Now can we take that inverse manually, do it by hand instead of graphing it? Of course we can. You remember the idea? We switch x equals y squared minus 4. So this equation, y squared minus 4, is your sideways parabola. Now we usually solve for y. So if in this case I do add 4 to both sides, and then the inverse of a square, or the opposite I should say, is a square root, I end up with this equation. So we're going to hold on for that for a second. Is that the inverse? Well, of course, we switch the x's and the y's, we solve for y. Of course this is the inverse. All right, let's take a look at the graph. So I am going to call this up real fast. And let's look at the graph of y equals the square root of x minus 4. Whoops, I'm sorry, it was x plus 4. What do you notice about the graph? Where's the other half? Why is it only this part? Well, if you remember, square roots only return positive answers in the real number system. And this is the graph of the real number system. We cannot take a negative number and take the square root of it and end up with a real answer. So what does that mean about this? Is this a function? Is this the inverse? How truly could we write the inverse? Well, technically, we would have to include both the positive and the negative values of that. So if I do it that way, I take another one, I do y equals negative, let's grab this back, the square root of x minus 4. Then you're going to notice now we've got the bottom. Now look at, if I did this here, remember what we had started with? X plus 4 equals y squared. Well, look at that. If I turn these two graphs off, that is the inverse. And these two graphs are right on top of it. So the question comes to be, this is the inverse of this function, but so is this. This is not the inverse of that function. However, when we graph these equations, unless there's a plus or minus out in front, we're just graphing what we see. Whatever we put in, that's what gets put out. So your graphs that we're going to be doing are actually going to end up having this shape to them. It's always going to be this shape. That is a shape of a square root graph. Okay? So let's look at number 1 here. The first one we're going to graph. So we're going to graph the square root of 5x. Now again, the shape is going to be something like this. Now it could be moved up, could be moved down, could be flipped around. If that was a minus outside, then it would be down this way. So how do we make sure we do this graph? Here is my suggestion, okay? I like to start at 0. What would make this the square root of 0? Because what is the square root of 0? The square root of 0 is just 0. So what x value would make this equal to 0? So 5 times what would be 0? Well, 0. So 5 times 0 is 0. The square root of 0 is 0. This starts right here. Now, since you know the general shape, and we're drawing a graph, it's not going to be perfect. Let's say we picked 1. Well, 5 times 1 is 5. The square root of 5 is a decimal. Now, could you find out that decimal and kind of graph it where it has to be close? Sure you can. But I'm a grid guy. I try to hit things that are right on the grid because it makes it easier to graph. What is the next x value that will actually give us a perfect square? So if we try 3, 5 times 3 is 15. That's not right. 5 times 4 is 20. That's not going to work. 5 times 5 is 25. It's the square root of 25, which we know is 5, a positive 5, not a negative or positive 5. The square root of 25 is just 5. 2, 3, 4, 5. 1, 2, 3, 4, 5. And basically, that's the only point that hits an exact whole number that's going to be on this graph. 6 times 5 is 30, 7, 35. 8 would be 40. 45 if it's close, but it's not going to be a perfect square. But that's all that we need, because we know that this graph goes up and hits this and just goes off that way forever. Now the next thing that I ask you on these is what's the range and the domain. I'm going to create what I call, I don't like that one, I like this. I like one that ends, hang on, let me see if I can fix this. Yeah, and we'll do that. I'm going to call this my range finder. Now I'm going to duplicate this. I'm going to change its color. And I'm going to make it, whoa, come on. There we go. I'm going to make it vertical. We're going to call this the domain finder. Whoops, because basically, remember, what you do is, if I take this graph, or I take this line, anywhere where it hits the blue, it's in the domain. So, it starts it right there. 0 is in the domain. So is 1, 2, 3, and every number in between. 4, 5, 6. If I go this way forever, will it never not hit the blue graph? No, the graph is going that way forever. So this domain finder, just made that up. Maybe I'll get a lot of money from it. So the domain is every x value that is greater or equal to 0. Starts at 0, goes to 1, 2, 3, 4, and on forever. Now the range finder, I go up till I hit the graph. Boom, and I hit the graph right there. There we go. Sometimes I'm smart. Okay, so the range finder, so you see it's not hitting the graph, not hitting the graph, and all of a sudden, boom, it hits the graph there. And will it hit the graph everywhere up? Is there any y value that it won't hit? Now you might be saying, look, this thing's going out like that, but it's kind of leveling off. Does it level off? If I take the square root of 1 billion, it's a pretty big number anyway. If I take the square root of 1 trillion, it's still moving up, isn't it? It's always moving up. Forever it is moving up. And it is starting right at 0. So both the domain and the range start at 0. So in this case, the range is all y values greater than or equal to 0. Okay? That is your domain and range. And that is your graph. And basically, that is all that we are doing. We'll take a break right now. And when we come back, we'll finish the rest of the worksheet.